Right guys, welcome back to the channel. Today we're going to be going through some exam style questions, but this time on complex numbers. Now this is again not particularly difficult questions, but they are still exam style. We'll get into the more difficult questions at a later date, but for now it's just good to get the basics done as to what you'll expect to find on an average exam paper. So firstly, what we've got here is the following. Okay, so without using a calculator, express the complex number 2 plus 6i in the form x plus iy, where x and y are real. So how do we do this? Well, the way I go about doing this is to say, okay, for ai, so we've got, 2 plus 6i over 1 minus 2i. Alright. Now, we need to express it in the form x plus iy. So, how do we do that? So, what I can say is that this is the same thing as saying 2 plus 6i 1 minus 2i times 1 plus 2i 1 plus 2i. So, this key thing here, guys, is I'm timesing by the conjugate. Okay, when I times by the conjugate, what do I get? Well, 2 plus 6i 1 plus 2i over 1 minus 2i squared. Okay, so key thing here is we're going to expand this out. What do we get when we expand this out? Well, what we're going to get is 2 plus 4i plus 6i plus 12i squared. Okay, over 1 plus 4. So what's this going to give us? Well, we're going to get 2 minus 12 plus 10i over 5, which gives us negative 10 plus 10i over 5, which naturally we can then get down to negative 2 plus 2i. Alright, cool. So that's number I. Simple enough. Now for II, we're going to have to express it in polar form. Okay, given the exact values of r and theta. So for II, we're going to do the following. Okay, well, using the result we got before, what we can say is, okay, fine. We need to find the absolute value of what we've got here. Okay, because we've expressed it in this form. So if we do this now, right, absolute value of, the magnitude of negative 2 plus 2i is simply going to equal negative 2 squared plus 2 squared. Okay, and so what's this going to give us? Well, it's going to give us root 8, which gives us 2 root 2. Right, cool. And the next part is to say, fine, well, what's the argument? So find the modulus. What would the argument now of negative 2 plus 2i? Well, the argument of negative 2 plus 2i is simply going to equal arctan of 2 over minus 2, which equals arctan, of minus 1. And this is pretty simple. From this, we can basically say that, okay, fine. We can say that from this, okay, that the basic angle is going to equal pi over 4, because tan negative 1 It's going to equal pi over 4. So let, should we say pi over 4. Right. Now, boom, boom, boom. So we got that. Now if I look here, okay, negative pi and pi. Right, so that's within the range. But we've got to realize that where we lie is in this quadrant, right? We lie in this quadrant. So what we're going to say, since we lie in this quadrant, we have pi over 4 there, but we lie in this quadrant, right? So we're going up like that, so therefore we're going to have to do pi minus pi over 4, which is equal to 3/4 pi. Okay. Cool. Now from there, it's a simple case of simply saying, fine, we found the argument, we found the modulus. So what do we say? Well, what we can say is that minus 2 plus 2i is simply going to equal the modulus 2, okay, times cos of 3/4 pi, okay, plus I sine 3/4 pi. Okay, and then this now, guys, is going to be your final answer. Alright, guys, now for number B, we've got the following. So, if you remember, this was our previous results. Okay, 2√2, and then cos 3/4 pi plus I sine 3/4 pi. Now for number B, it says on the Argand diagram, shade the region whose points represent complex number z, satisfying these two inequalities. Okay. Find the greatest value of argz of the points in this region, right? So how do we go about doing this? Well, first thing we need to remember is, if we look here, z 3 minus I. Okay. So z, the absolute value of z, sorry, magnitude there, z minus 3i is the same thing as saying z minus 0 plus 3i. Okay. And why do I do this? I do this because this basically represents it in a little bit more official form in the complex numbers context. Here we've got the real number 0 plus 3i. So essentially, if we have an axis, we draw this axis now, it's going to look like the following. Okay. And 0 plus 3i, so we're going to have the 3 up here. Okay. In essence, it's 0, 3. Okay. We got real, imaginary. That's the first thing. And just to make things simple, I'm just going to draw a line here. Got 3 there. Now, what does this actually say? Well, if you think about it, okay, z minus 0 plus 3i equals 1 is basically the same thing as having a circle where the radius is equal to 1, okay? But where does the 3i come in? Well, the 3i comes in the fact that the 3 is going to be the center of the circle. I'm going to have a radius 1. So here's what I'm going to do. I'm going to take this circle now, and I'm going to put it over the 3 here. Cool. So what's our first condition here? First condition is that real z is smaller than 0. Okay, so if real z is smaller than 0, that means we're all going to be on this side, okay? Cool. That's the first part. We're all going to be on this side over here. Okay, now the second condition here is that this has to be satisfied. Okay, so if this here has to be satisfied, well then essentially what we're going to get is we're going to get some kind of angle here, okay, because it's going to be everything within the semicircle, right? And what we can say is, okay, fine, this is what needs to be satisfied, but the greatest value of the argument z is what we're looking for. And the greatest value of the argument z is going to be where the tangent here touches the circumference of the circle. Okay. We've got a right angle there. So I'm going to call this point here T. And I'm going to shade in this area quick. Okay, because that's what's represented by the conditions. And so we can say the following. Well, this over here is obviously a right angle triangle, right? I'm going to call this angle here alpha. Okay, so then what can I say? Well, sine alpha is going to equal, well, what? Opposite. What's opposite? That's 1 over hypotenuse. What's the hypotenuse? 3. Perfect. And so if we find alpha now, alpha is therefore going to equal 0.34 radians. Okay. Now, the thing to represent is to say, okay, cool. Well, we've got alpha now. How do we find the greatest value of arg z? Well, the way we find the greatest value of arg z is to remember that arg z encompasses this entire angle. Okay, like this. So we've got alpha, and we know what this is. This is pi over 2. Okay, so therefore we can say that the greatest value for arg z is equal to pi over 2 plus 0.34, which equals 1.91 radians. Okay, and that, guys, is going to be the final answer to that question. Alright, guys, now for question 3, what we've got here is complex number -1 plus root 3i is the root of the equation kx cubed plus 5x squared plus 10x plus 4 equals 0. Okay, write down another root of the equation and find the value of k in the third root. Okay, standard question. So how do we do this? Well, first thing is, well, listen, the other root is just a theory thing. So the other root here is going to be -1 minus root 3i. Okay. Why? Because when it comes to your roots of the equations, it's always going to be a plus I root b and a minus I root b. Okay, that's standard. Now we get to the real stuff. Okay, so let me hide this a little bit. So I. Find the value of k and the third root of the equation. So how do we do that? Well, the first thing we have to do is sub. Okay, we're going to substitute -1 plus root 3i into the equation. Okay, Now what do we get when we do that? Well, what we get when we do that is we get k negative 1 plus root 3i. Okay. 3 plus 5 negative 1 plus root 3i squared plus 10 negative 1 plus root 3i plus 4 equals 0. Okay. Brilliant. So, what do we get from here? Well, what we get from here is the following. We get k negative 1 plus root 3i. Then we get negative 1 plus root 3i squared. Okay. Plus 5. Plus 5, and then this is going to multiply out to the following. Excuse me. Let's see. Okay, and it's going to be minus 10 plus 10 plus 10 root 3i plus 4 equals 0. Okay, brilliant. So, now that we have that, we can get to the next bit. Okay? So, you can say k root 3i. Okay, then we get 1 minus 2 root 3i minus 3. Okay, because this is gonna multiply out. Okay, plus 5. What are we gonna do here? Plus 5. Yeah, minus 2 root 3i. Okay. Minus 2. See, minus 6. Plus 10 root 3i. Okay, because all I've done is like simplify it a little bit. Equals 0. Right. So, from here, we say, okay, cool. We just keep simplifying it down. Let's get k. You can skip this bit. This is a bit boring. This is just going through it. Negative 1 plus root 3i. Negative 2. Minus 2 root 3i. Minus 10. Okay. Minus 10 root 3i. Minus 6 plus 10 root 3i. That's going to equal 0, guys. And then from here it's just a case of, well, simplify things down. Okay? So we can say the following. What we've got is k, 2, plus 2 root 3i, minus 2 root 3i. Okay, and we're going to have plus 6 here. Okay, because this is going to multiply out with this. Let's give us 6. Okay, and then finally, these are going to cancel, and what we've got is negative 16. Alright. Okay, cool. So, from here now, let's see what we can do. Well, 2 3i. So So these are going to cancel. Essentially what we get here is 8k minus 16 equals 0. 8k equals 16, which means that k is going to equal 2. Perfect. So now we've got k is equal to 2. We can now expand this further. So we know, okay, we've got k equals 2. Alright, now we need to find the third root. Now, we know that x equals negative 1 plus root 3i, and x equals negative 1 minus root 3i are roots. Okay, we know that. We can then say that we've got a quadratic factor. Therefore, we can say negative 1 it's going to be x plus 1 minus root 3i. Okay, and x plus 1 plus root 3i. This is a factor. Okay, and all we have to do now is expand this out. Okay, so when we expand this out, what do we get? Well, what we're going to get is, of course, we get x squared plus x okay, plus x minus okay, minus root the x minus root the I minus 3i squared plus 4. That's going to equal what? Plus 3. Alright, so 3, negative 3, yeah, negative 3 times I squared, well, yeah, plus 3. Cool. Now we can break this down a little bit. So these are inevitably going to cancel. The x's are going to get together. Boom, boom, boom. Okay. So what we get here is x squared plus 2x plus 1 plus 3. Yep, so we got plus 3. And this is very much going to just equal x squared plus 2x plus 4. Okay, so we've got our quadratic factor here. Perfect. Now, if we've got a quadratic factor, we can then say the following. Well, if this here is our original equation, and we've got a quadratic formula here, quadratic factor here, we're going to use long division to find the third root. Okay, so what we've got, and you can see how everything builds up throughout the course, right? While the algebra bit at the beginning is so important. Okay, we've got x squared plus 2x plus 4, and then we got k, x cubed, so it's going to be 2x cubed plus 5x squared, okay, plus, what's the next bit, 10x plus 4. Okay, cool. So now we just use our long division. So x squared going to 2x cubed, so that's going to be equal what? It's going to give me a value of, no, that's going to equal 2x. Okay, so take this, multiply it back in, minus 2x cubed plus 4x squared okay, 2x minus 5 that's 4, well, that's going to equal x squared, 10 that's 8, that's 2x. Okay, and we're just going to have the plus 4 at the bottom here. Right. Okay. Now we're going to divide this back in, so x squared into x squared. That's once. Boom, boom, boom. That's going to give me what? X squared plus 2x. X squared minus x squared. Well, 0. 2x minus 2x. 0. 4 minus 4. 0. Alright, so very pretty simple equation here. So therefore what we can say is this is going to be the third root. So therefore, so third root is 2x plus 1. And what else do they want? And the third root of the equation, so say 2x plus 1 equals 0. Sorry, third root is 2x plus 1 equals 0. And so we can say then therefore that x, the actual third root then is going to equal negative a half. And that is going to be the final answer to that question, guys.